The way we're going to do part A is going to dictate how we do the other three parts. It's going to hurt a little bit, but it's going to be okay if you are comfortable with fractions. So I'm going to give you the intermediate step, and then we're going to go right for the good stuff. A square root is a 1/2 power. When you have a power to a power, you multiply the powers. Nine halves is bigger than 1. So let's write this as a mixed fraction. So whole part, fractional part. 9 halves is the same thing as what mixed fraction? 4 1/2. 4 1/2 implies 4 plus 1/2. So that means this is the same thing as x to the 4th, x to the 1/2. Let me erase that, it's getting sloppy up there. Yep. Four to the 1/2 is the same thing as 4 plus 1/2. I'm sorry, 4 1/2 is the same thing as 4 plus 1/2. So when you have a base to a sum, you can break it up as a product. That was our number one exponent rule in reverse. Well, 4 is whole, so that can stay on the outside. 1/2 is still a fraction, a proper fraction, so I can write that as square root of x. So the square root of x to the 9th is x to the 4th times the square root of x. That is the very long way. And we're not going to do that very long way anymore. Instead, here comes the shortcut. What is the index on this radical? 2. 2 goes into 9 how many times? 4 times. So we can pull out a 4, and how much is left over? 1/2. Done. So you can go from here to here in one step. So 2 goes into 9 4 times. Pull out x to the 4th. How much is left over? 1. Do not ever change the index of the radical. If you start with a square root, you're probably going to end with a square root. So when we go to do part C, if you lose your 4, then you turned your 4th root into a square root. That's not good. It's not comfortable. Yes. And it's also not legal in this state. There's a bill in Congress. For C, B, C, and D, yep, for the rest of the page. Ready? Okay. Here it comes. What's the index on B? 2. We're going to do the x first. 2 goes into 3 how many times? 1 time, so I can pull out an x. How much is still left over? 1x. 2 goes into 6 how many times? So I can pull out a y cubed. How much is left over? None, so I don't put a y underneath my radical anymore. 2 goes into 9 how many times? So I can pull out a z to the 4th. How much is left over? 1z. Done. No. 2 goes into 6 3 times. Is that okay? Say. 4 goes into 5 how many times? So I can pull out 1x. How much is left over? 1x. 4 goes into 3. It doesn't. So we still keep the y cubed downstairs, underneath the radical. 4 goes into 8 how many times? How much is left over? None. Don't lose the 4 on the radical. It's still a 4th root. Well, it is a fraction because it would be 3/4. But since it's less than 1, you can write it as a radical. All right. So part D is just like our previous guys, because our 250 is not a perfect cube, but it contains one. Which one does it contain? Negative 125. Good. So let's do this in stages. So I'm going to write side work over here. The cube root of negative 250, based on our previous work, ends up as negative 5 cube root of 2. And the previous work was what we did before. This was positive 250. So negative 250 has a negative in front, which we can do because it's an odd index. So negative 5 is on the outside. And for our radical, the 2 goes on the inside. So now let's do our variables. 3 goes into 12. So we can pull out an x to the 4th. 3. Oh, and by the way, there's nothing left over, so no more x under the radical. 3 goes into 19 6 times. How many are left over? 1. 18. 3 goes into 10 3 times. 1 left over. I gotta fill this room up. Perfect. Don't lose your 3, otherwise you're turning it into a square root.